Hello everyone, welcome to Technologies Discussion Channel. Today, I'd like to continue the discussion on parameters, okay, such as S parameters and also ABCD parameters. If you have followed this channel closely, okay, I have discussed extensively what is S parameters, what is ABCD parameters. This video, okay, I'm going to concentrate, okay, why we need to convert S parameters to ABCD parameters. So this will be the objective of this video. Okay, so basically I will show you an example how can we actually convert S parameters to ABCD parameters. On the Part 8 series discussion, okay, I will show it to you when we actually convert into ABCD parameters, we can actually, in fact, cascade the circuit together. Once we cascade the circuit together, again, the role is now to return back the ABCD parameters to S parameters. So again, I will have an example to show it to you. How can we actually convert the ABCD parameters to S parameters? In short, this video will show it to you, okay, why we need to convert parameters from one form to another form. For example, from this video, you can see that I basically convert the S parameters to ABCD parameters. After that, we will be utilize these ABCD parameters to cascade the circuit. And then last but not least, we will convert the overall ABCD parameters to overall S parameters. So this will be the objective of this video. This will be the Part 7 series discussion on S parameters. So guys, if you're keen to know more about S parameters, okay, please take a look on the playlist, okay, under the description. Over there, you will be able to find a series of discussion on S parameters. This is my email. If you have any question regards on this discussion, please drop me an email, okay? Or if not, if you want to have a faster response, okay, you are always welcome to ask me through the comment. Okay, before I continue, I'd like to urge you guys to help this channel by like this video. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for your strong support. Let me quickly do a quick introduction to S and also ABCD parameters. Okay, let's start by discussing on the S parameters. But before I go into detail on S parameters, okay, maybe for a start, let me quickly mention what is actually a Z parameters, which is also the impedance parameters. Okay, these Z parameters or impedance parameters, okay, in fact, is the most intuitive form of network analysis. Okay, which means that Z parameters is often used when we actually want to describe some form of network analysis. However, there is one big disadvantage of using these Z parameters, okay, or impedance parameters, and also admittance or Y parameters, is because they are impossible to measure directly at high frequency. Okay, so most of the time, Z parameters or Y parameters, they are only utilized at DC value. DC means low frequency. This form of metrics basically are not able to measure directly, especially at higher frequency. Okay, fortunately, okay, this issue can be easily resolved by using S parameters. When we actually utilize S parameters, then we can measure directly at high frequency. Okay, so if you want to understand why, okay, please take a look on the S parameter discussion. Okay, basically when we actually use S parameters, okay, we actually minimize the issue. When we actually having this Z and Y, okay, it almost very difficult to describe a 0 ohm impedance or maybe infinite impedance. It's almost very challenging to describe this. However, okay, all this can be resolved when we actually use these S parameters. Okay, S parameters assume that each port is terminated with a certain value, typically will be 50 ohm. Okay, so basically all the port that we actually describe by using S parameters, they will terminate with a 50 ohm most of the time. Okay, it is relatively easy to convert Z parameters into S parameters and vice versa. Okay, so basically in short, okay, we can always use this impedance, okay, parameters to describe a network. Okay, however, they cannot be done at high frequency. So on another way, we actually use S parameters to describe such a circuit. Let's quickly go into ABCD parameters. Consider a two-port network. Okay, if the voltage and current are measured at the input and output port, the system can be categorized in terms of ABCD parameters. Okay, so in short, for ABCD matrix, basically we are describing input versus the output. Basically, I'm describing this, what it will be the input, what will be at the output. So basically, this is in short what is ABCD parameters. Okay, the ABCD parameters offer several advantages over other network parameters. Okay, they allow for full description of network in terms of input and output voltage and also current, can make them very convenient when we actually want to cascade a circuit. Okay, when we actually cascade S parameters, okay, one of the most useful aspect of network analysis is the ability to cascade independent measure structure, okay, which means that it's always very frequent that we actually have some individual, okay, parts or components that we actually need to cascade them into a one form of system, okay, in order to work. So therefore, okay, basically, when we actually want to do this, it's always very attractive to do this in a cascade network analysis. Okay, for example, okay, if the S parameters are measured independently for a transmission line, okay, via package and connector, okay, the engineers can actually create the response of an entire channel from the individual measurement. Okay, this allows S parameters file to be used as portable mode, given the designer the ability to evaluate different topology and provide a mechanism to de-embed or calibrate out unwanted item in the measurement. Okay, the two most common form of cascading S parameters are using ABCD matrix and also T matrix. Okay, but over here, mainly I will focus on ABCD parameters first. Okay, on maybe on my next few videos, then I will have some discussion on T matrix. Okay, so basically, let me explain. Okay, so for example, here we have this VR. Okay, when we actually have this VR, we want to describe them in S parameters. Okay, let's say we are going to utilize them at high frequency. Then we can only use S parameter to describe the characteristics of the VR. Okay, so if you still remember for S parameters, okay, we always have input and output port. Typically, most of the time will be 50 ohm. So basically, let's say this will be the S parameters, okay, to describe the performance of this VR. Okay, we have this transmission line. Again, this will be the input and output impedance. And basically, when we actually have these S parameters, basically these S parameters will describe the performance of this transmission line. Okay, so basically this will be the S parameters. Mainly want to focus to describe the transmission line characteristics. So what happened here is basically when we actually put these two things together, we have this VR, we have this transmission line, we want to put them together. So how can we actually achieve the overall S parameters? In short, I have this, I want to join this with the transmission line as shown it over here. So now I want to calculate my overall S parameters. How can I do this? Okay, let me quickly go through this. Okay, for example, now we have this S parameters. Okay, remember when we actually cascade, we need to use ABCD parameters. So therefore, I have this S parameter typically will be described in a data sheet, for example. Then I can convert these S parameters into ABCD parameters. So this will be the ABCD parameters for the VR. Same as for the transmission line. Again, these were the set of transmission line S parameters. Okay, so again, from here you can see that I will show it to you later on an example. How can we actually convert the S parameter into ABCD parameters? So these ABCD parameters will use to describe just for the transmission line. When we actually cascade them together, okay, basically I can easily utilize these ABCD parameters to calculate the overall ABCD parameters. In short, this will be the ABCD for the VR. This will be the ABCD for the transmission line. If I cascade them together, then I will be able to find the overall ABCD parameters. And then last but not least, with the calculate ABCD overall parameters, I can also easily convert them into S parameters. So basically, these S parameters will describe the overall S parameters network analysis of the VR added the transmission line. In short, for this video, okay, I'm going to show it to you how can we actually convert the S parameters to ABCD parameters. This I will show it to you on part 8 series discussion. Then I will show it to you how can we actually cascade the ABCD parameters and also change the ABCD parameters back to the S parameters. So this will be on the part 8 series discussion. Part 7, I will do these two. Part 8, I will do another two. Okay, so this is from the POSA book. Okay, so over here, you can see that I will be only utilize these two. For example, okay, if I want to get S parameters from the ABCD parameters, these are all the formulas. I say this again, for example, if I need to so-called obtain the S parameter, in short, convert ABCD parameters into S parameters, then I will use this equation here. As for here, for example, I need to have ABCD parameters. I actually convert the S parameters into ABCD parameters. Then I will use this set of equation. Okay, so don't worry, later on you will see an example and you will be very clear how to do this. Okay, before I continue, okay, if you have learned something from this channel, please consider to like and subscribe to this channel. Okay, once again, thank you so much for your time. Let me continue. Okay, so this will be the example. Okay, using two independent measure values of S parameters for a via and also a lossless transmission line at 5 GHz. Okay, so typically for 5 GHz is considered a high frequency. So therefore, we can only use S parameters to describe both the via and also the transmission line. Okay, so we are tasked to calculate the equivalent S parameters, okay, that will be measured if the two circuits will cascade as shown below. Okay, assume the termination impedance is 50 ohm. Okay, which means this is 50 ohm, this is 50 ohm. I have the VR, okay, I have the transmission line, and basically I have the S parameter to describe the VR as shown over here. I have also the S parameter to describe the transmission line as shown over here. So now I'm going to show it to you how can we actually convert the S parameters into ABCD parameters. Okay, so this is a so-called equation that I showed it to you earlier on. So basically, from here you can see that I actually convert the S parameters into ABCD parameters. So basically, this is the equation that I showed it to you. Okay, so basically these are given to me. These are the VR that is given to me. So these are what I'm having over here from the data sheet, for example. I actually copy down into here, okay, to make the discussion easier. Okay, so the first one, I will go a little bit slow. Okay, the rest, I will go a little bit faster. Okay, because more or less you already understand how this thing can be done. Okay, let me quickly go through this. So this will be the A. So the A will be using this formula, as you can see from here. So this part is actually copied here. This will be the A parameters. This is how we can convert the S parameters into ABCD parameters, making use of S11, S22, S12, and also S21 here. So basically, we are ready to do this. So basically, 1 plus, so this will be S11. So from here, you can see that S11 will be this number, okay, minus 0.1235 minus J 0.1516, which is here. Okay, and then another one minus, okay, S22. S22 will be equals to minus 0.1235 minus J 0.1516, okay, which is over here. So this is plus, this will be S12, this will be S21. Okay, S12, okay, you can actually obtain from the number here, and S21 the number here. So basically you can see I just copied it down. So this will be 2, okay, and then multiply by S21. Okay, so basically S21 will be 0.7597 minus J 0.6190, which is illustrated here. Okay, before I continue, okay, let me share you an apps can easily calculate, okay, this thing. Okay, so basically I like to show it to you. Okay, but you can see over here, all my calculation, they are all in full. Okay, because in exam, you probably cannot utilize any app. Okay, but over here, okay, actually nowadays, we can have many forms of apps to do the easy calculation of this. Okay, but like what I mentioned over here, I will show it to you quickly. Okay, but you can see over here all the calculation. Okay, they are in deep detail so as to prepare you to do this for your exam. Okay, so let's go into the apps and see how can the apps actually help us to convert them from different forms. Let's quickly go to the apps. Okay, so this is the apps, or this is the so-called the app we can actually use to do complex number calculation. Okay, I will leave this link under the description. Okay, so basically, let me quickly show you to you how this thing can be done. Okay, for example, you can see that these are whole chunk of numbers. So I'm going to copy this whole chunk of numbers. Okay, over here you can see, I just copy this whole chunk of numbers. Okay, and I'll do a Control-C to copy, and I paste it over here. So basically, these are all the whole chunk of number, and I press the word calculate. Okay, so once they calculate finish, you can see that these are all the calculate. So this whole chunk basically on top will be 1.2023, okay, which is quite similar what I calculate manually. So basically from here, you can see that the apps can do this in a split second, okay, which I need to spend quite a amount of time to calculate, quite tedious. But over here, you can see that the apps can easily find this number, okay, just by cut and paste, and you can show that the numbers are actually quite close to each other. Okay, so with this, let me continue the discussion. Okay, how can we actually convert the S parameters into ABCD parameters? Okay, so you have seen how apps can actually help us to do the conversion. Okay, so basically from S parameters into ABCD parameters. Okay, over here, these are all the manual calculation. Okay, so I just want to show it to you as I mentioned. Okay, just in case you are doing this for your exam, you are not allowed to bring your PC. So therefore, let me quickly do this. Okay, so from this equation here, okay, basically I'll obtain this. So basically this is S11. Okay, so S11 from here, this will be S22. This will be S12, and this will be S21. And basically, this will be S21 also. So basically, with this, okay, I actually work up this term first. So this term is actually arrived at this solution here. And I work up this term here. Okay, basically, this term is actually over here. And the behind, I actually multiply together to get this. Again, before I do this, I always need to clear the multiplication first. So I work these two terms into one term here. And then the rest the same. Okay, so last but not least, I combine them into one. And finally, I have obtained this answer. Okay, but I see that the imaginary number will be very, very small. So hence, I decided just to keep this 0.79, okay, as the number to move it forward. So basically, this is the value of A, okay, in the ABCD parameters. The next, how we actually can calculate the B term. Okay, so basically from the B term, you can see that the formula as shown over here. So I just plug this thing down here. Okay, so basically Zn, okay, which is the so-called the reference impedance, which is 50, which is given. This will be the S11, this will be the S22, this will be S12, and this will be S21, same as this S21. Okay, so I have calculated the S21 before. So this is how I get this. And from here, you can see that it's the same way. So basically, I done this. This will be the first part. I will quickly do this. This will be the part. These two are multiply will be over here. Okay, so again, as I mentioned, okay, all the multiply we need to do first. So I multiply this to get this term here. Okay, and then this term will be probably down the same here. So next, I'm going to do the top bottom here. So basically, I get this number and everything multiplied by 50. Okay, as you can see, this thing I divide, I get this number and I multiply by 50. Okay, over here, you can see that now the so-called the real term is quite small. Okay, 0.03, which is quite small and will be quite insignificant. So therefore, I only have the imaginary number, which is J22.22. Okay, so basically, this is how I obtain my B term. Next, on my C term here, so basically, this is the formula to calculate my C term. Okay, I put it here. Okay, again, I'm ready to do the equation. This is 50, 1 divided by 50. Okay, this will be S11. This will be S22. This will be S12. This will be S21. Same as this will be S21. How I do is exactly the same as A and B. Okay, I'll do this part first. I'll do this part. Okay, and then everything I just bring it down. Okay, so these two parts, I will multiply them together to obtain this part here. Okay, so this part I just remain same for here. Okay, so next, okay, basically you can see that over here, the final equation I showed you over here, okay, the real term, okay, is quite small, so I neglect it. So basically, I just concentrate on the imaginary term, as you can see from here. So basically, this will be the number C term here. Okay, as for D term, okay, so basically, this is for the D term. Okay, so basically, the D term formula is here. So from here, you can see that this is 1 minus S11, okay, 1 plus the S22, and this is S12 and S21. Okay, so basically how to do all this, I guess that is quite clear and straightforward now. So basically, at the outcome will be these two, the imaginary term will be quite small. So hence, I only just want to concentrate on the real term, which is 0.7905 here. So basically over here, you can see that I have successfully, okay, covered the S parameters of the VR into ABCD parameters of the VR. So basically, this will be the ABCD parameters for the VR. Okay, as for the transmission line, okay, basically, I will not be able to show it to you. If not, the length of the video will be too long. I believe you are able to do this on your own. So basically, over here, basically, you can see, okay, once I convert the S parameters of the transmission line into the ABCD transmission line, I will have this value. So basically, these are all the parameters for the ABCD for the transmission line. So on the step 2, okay, basically what I need to do is basically I need to multiply the ABCD parameters, which means this multiplied by this, which I will further discuss on the part 8 series discussion. With this, I'd like to end my discussion. Please help to like and subscribe. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you.